I bought a new saw, so to fit it in my crowded shop, I'm going to build a flip cart that lets me house it along with another tool in a single cabinet and then just flip the top over when I want to switch tools. I'm going to build my flip cart a little differently than some others I've seen for a couple of reasons. First, I'm going to have both a wood and a metal saw in the same cabinet. I'm doing it this way because I don't have enough space in my shop for separate wood and metal facilities, and instead I just take care not to let the dust from one set of tools get in the other tools. For the flip cart, I'm going to build cabinet doors that close around the bottom tool to keep the dust out. Second, these are pretty big, heavy tools. That's a 12-inch wood saw and a 14-inch metal saw. So the cabinet with the tools in it is going to come out quite big and heavy, and I'm going to use fairly heavy-duty construction techniques for it. For example, I'm going to use angle irons as support members. These angle irons will also let me build infeed outfeed tables that can be raised and lowered without adding a lot of additional width to the cabinet, for reasons I'll get into later. Here's a preview of how the flip cart came out. If you like this video, please click like and subscribe. My first step is building the drawer. I'll use lower grade plywood for most of the project, but because this will be a large drawer, I'm using a piece of Baltic birch left over from a previous project. Baltic birch is stronger and also looks nicer with fewer plywood voids. I assemble the drawer with pocket hole joints, glue on the back face, brad nail and clamp it, and then flush trim the edge with a router. I've seen several flip cart designs that use a piece of black iron plumbing pipe like this as both an axle and a conduit. So there'd be a couple of segments of pipe that are screwed into a T-connector in the middle, a power wire would run in from the outside out the T to wire up the tools internally, and then the pipe segments would be held in place by a couple of oversized flanges screwed in the outsides of the cabinet, with the pipe just resting in the flanges to rotate. I like the simplicity of being able to wire in through a T-connector. However, I'm not able to use pipe because my tools are quite heavy and I want to use bearings, and I found that the closest size pipe I could get to fit in the bearings would have required grinding off enough pipe that I'd be left with less than 1/16 of an inch of thickness, which I don't believe would be strong enough. Instead, I'm going to use steel tubing, which uses a different measurement system than pipe. I was able to get close enough to the size I need that I'll just need to grind off a little bit, and I'll be left with more than 1/8 of an inch thickness of the tubing inside the bearings, which will be quite strong. I'll run a power wire into the tubing, like I said before, and I'm going to use a strain relief like you find in a circular saw or angle grinder, so that the power wire coming in will be resting against rubber instead of chafing against steel. Because I'm not using a T-connector, I'm going to have to drill a hole in the middle of the tube, and I'm going to put a bushing in place to protect the wire coming out of that hole. I'm going to use a barrel bolt to hold the flip top in place so it doesn't rotate while I'm using it. I'm going to cut off a couple of segments of tube for the barrel bolt to go into and glue them into the cabinet. Now, one other thing I want to point out that I like a lot about using the bearings is that it has a couple of set screws on the bearings that will lock onto the tube. And what that'll mean is once the whole system's in place and screwed together, the walls will be effectively constrained from being able to bow in or out of square, which I think will be important because it's going to be quite a tall cabinet. Next, I build the cabinet. I use the track saw to cut the pieces that are too large to cut safely at the table saw, and then use a table saw with the smaller pieces. I then cut the recesses where the flip top will round with the circular saw and use the jigsaw to finish off the cuts. I cut out a couple of segments of steel tubing to use as anchors for the barrel bolts and then glue them into the cabinet walls. Cutting the close-fitting tubing caused it to deform slightly and no longer fit, so I grind a little bit of metal from the opening. I used the domino joiner to cut mortises for cabinet door backstops. I built both backstops from one domino, cutting holes for the rare earth magnets so it will hold the doors closed. I then cut the two backstops apart at the bandsaw. I drill holes in the cabinet for the door hinges and then assemble the cabinet. I use 90-degree clamps during cabinet glue up and a carpenter's score while driving the screws. I install some full extension drawer slides and mount the drawer in the cabinet. I use number 12 sheet metal screws because I find their larger diameter and heavier threads provide more strength when screwing into short distances of plywood. Next, I attach the drawer face using cardboard strips to set uniform edge gaps. I pull the drawer out, careful to avoid changing its position, clamp it in place, and then drive screws from inside the drawer. Finally, I attach a drawer pull. Part of the plywood was delaminating and breaking off the bottom of the cabinet. To address this, I chiseled out a rectangular area and then cut out a piece of wood with matching dimensions and glued it in place. I then filled the voids with some metal reinforced Bondo. I built a template for the caster screw hole layout and then drilled holes and attached the casters to the cabinet. At this point, the cabinet and hardware were too large and heavy to safely pick up by myself, so I moved the workbench under the shop hoist and then used the hoist to move the cabinet from the workbench to the floor. I'm going to use these folding brackets to support my infeed and outfeed tables. They're rated to handle 550 pounds of load per pair. Now this creates a design problem. If I were to just mount these brackets at the top of the cabinet like this, then when I raise the table, it would be at the height of the bottom of the saw instead of the saw base where it needs to be. I could address that by adding some additional pieces of plywood to pad it up to the height of the saw base, but that would mean in the lowered position it adds width to the cabinet. In my case, between the infeed and outfeed tables, it would add about 7 inches of additional width to an already large cabinet, and I don't want to use up that much space in my shop. Instead, I'm going to use a piece of 1/8 inch thick angle iron to mount each of the brackets. The idea is because angle iron is stiff and very strong, I could run a piece of it from the bottom of the cabinet past the top of the cabinet to the height of the saw base, and then just attach the bracket right where I need it to be. The angle iron will also add structural rigidity to these tall cabinet faces. Now, there's another problem I'm going to need to solve. This angle iron isn't quite the right dimensions that I need. It's the right dimension this way, but it's too tall, which would interfere with the opening and closing of the infeed outfeed table. So I'm going to take off about a 1/2 inch on the plasma cutter. I cut 4 lengths of angle iron from the 20-foot piece I purchased from the local steel yard. I used 3M bristle discs to remove the mill scale, which I find work better than other abrasive discs I've tried. I also think they're an interesting technology made with steel-embedded plastic bristles. I use a 3/4 inch piece of aluminum flat bar as a cutting guide, and then use the plasma cutter to cut a little more than a 1/2 inch off the faces of each of the angle iron segments. I use an abrasive disc on the angle iron to clean off the dross left by the plasma cut. I then switch to a flap wheel to remove any sharp edges that a finger might come into contact with. I built a template for the screw hole layout. I use it first to drill the cabinet holes, and then to drill holes in the same positions on the angle irons. I cut countersinks in the bottom holes where the wood screws will go. I then drilled the 4th hole in each of the support brackets because one of the factory drilled holes turned out to be in an awkward and unusable position. I drive the wood and sheet metal screws to the angle irons and support brackets, followed by a through bolt for the top hole. At this point, I realize I have a problem with my plan to run the axle through an oversized hole in the cabinet out to bearings mounted on a piece of 2x6 attached to the outside of the cabinet. Doing that would interfere with the outfeed tables in the lowered position. My revised plan is to cut away a rectangle in the cabinet in which to place a piece of 2x6 and then lag screw the bearings into the 2x6. To support the 2x6, I attach an additional layer of 3/4 inch plywood to the outside of the cabinet using glue and screws. I build a fillet from wood glue and fine sawdust, which I use to fill any voids left by imperfectly squared jigsaw cuts. I do this because I want to maximize strength in this key part of the mechanical build. I then glue in the piece of 2x6, followed by 2 toe screws and 2 6-inch screws driven down from the top. I realized the 1/4 inch bolts I was using at the top of the support brackets would stick past the space used when turning the flip top, so I switched to some lower profile bolts. I cut the replacement bolts down in length, clean up the threads of the bench grinder, and then tap the bolts down to full length. Next, I ground about a 64th of an inch away from the axle ends to get the axle to fit in the bearings. I then drilled a hole in the center of the tube for the power wire, deburred the inside of the hole, and used a piece of emery cloth to remove any remaining sharp points. To get the strain relief to fit inside the steel tube, I grind a few inches of the weld seam away using the narrow belt sander. This is my first time working with these bearings, and I found when I first installed the steel tube, the bearing would wobble a bit while the tube was rotating. That happens because the tube is not perfectly aligned with the axis of rotation of the bearing, and that was happening in turn because of the design feature of these bearings. These are called pillow bearings. They're free to move within the housing. And the problem was that one of the bearings was particularly stiff, and what I needed to do was apply some grease to these two grease joints and then distribute the grease around the bearings. Once I did that, the tube now is able to get aligned with the axis of rotation of the bearings, and it works great. Installing the bearings into cutaway sections of the cabinet left holes at the top of the cabinet, which I'd like to cover, both to keep dust out and to make the cabinet look more finished. For this, I cut out a couple of rectangular pieces of 18-gauge steel, drilled screw holes, and then cut semicircles out of each to fit against the bearing housing. I cleaned up the cuts with a grinding drum, testing the fit a few times along the way. I then cut away some notches to leave tabs, which I folded the sheet metal bending brake to fit into the cabinet opening. The lag screw heads interfere with the cover plates closing all the way, so I remove a small amount of the bottom edge at the wide belt grinder. I then clean up the exposed faces at the burnisher. I glued a spacer block onto one side of the flip top to bring the wood saw's base to the same height as the metal saw, so the infeed outfeed tables are aligned with both saws. I center the wood saw over the spacer block and then hammer bolts into the mounting holes to mark their positions. I then do similarly to mark the positions for the metal saw on the other side of the flip top. I want to be able to take a saw off the flip cart easily so I can use it outside my shop. So for this I have a couple design ideas. First, I want to be able to drive the bolts that hold the saw in place down just from the top without having to hold on to a nut with a wrench underneath. So for that, what I'm going to do is glue some pieces of wood up on the inside of the flip cart top and then drill some holes slightly smaller than the diameter of the nuts and pound the nuts up into those holes so they're held in place by the wood. I tried this first with a piece of plywood, but I found it was too soft. The nuts got pulled up through the plywood. So then I switched to a piece of hardwood. This is some cherry leftover from a previous project. For strength tests, this is a spacer that represents the height of the saw, and I have a nut already in place. So you can see that grabs well, the nut doesn't get pulled through the wood, and I can just do it all from the top. The second design idea is to use these power supply cords that are designed for computer workstation desktops. They're just, you drill a hole in the top and then you just hold it in place with a simple screw mechanism. So I'll have these in the tops of the flip cart top sides, and then I can just plug this saw and unplug it right from the top. I draw the framing layout on the inside of one of the flip top faces and then cut out 2x4s for the frame, along with pieces of hard maple left over from a previous project to use as axle supports. I then use a self-centering punch to mark the centers of the indentations left from hammering the saw mounting bolts. Next, I drill a small hole at each punch center to expose a hole on the topside face, and I also drill holes for the power outlets. I then glue the nut retainer strips in place. I next flip the top over and drill small holes from the front faces into the nut retainer strips, and then flip the top back over and use the small holes to center and drill slightly undersized holes for the nuts, followed by slightly smaller holes for the bolts. I then pound the nuts into the retainer strips. I set up the drill press table to drill holes in exactly the same position for each axle support and the two outer frame pieces. I then cut dados for running the power wires and for fitting the axle supports over the nut retainer strips. I next cut dominoes for joining the four outer sections of the frame, which I'll later reinforce with screws. I then plane down the conduit screw down blocks so they end up slightly below the bottom of the axle for maximum clamping strength and cut the pieces to length. I assemble the parts of the electrical junction box that I can put in place before the frame assembly, including box connectors, the ground wire, and attaching the box to the frame piece. I drill holes from the inside of the flip top according to the layout drawing, pre-drill holes into the frame pieces and then drive screws slightly past the inside face to make it easy to locate the frame during glue up. I then assemble the domino joints and apply glue to the flip top inner face and position the frame aligning with the slightly driven screws. I then drive the screws all the way into the frame and apply clamps. I push the axle through the support blocks, then glue the blocks to the flip top and drive screws into each. I apply beeswax before driving screws into the hard maple to reduce chances of snapping the heads off with the impact driver. I then glue and drive screws from the frame into the axle support blocks. I install the hard maple blocks under the axle, glue them down to the inside face, drive screws from the top side, and then install pipe hanger straps to secure the axle in place. This is quite a heavy build and certainly over-engineered, but I want this central structure to be very strong and rigid to support smooth rotation of the flip top with heavy tools attached. I now attach the bearings, tightening the set screws in place to lock the flip top in position. I drop the flip top into the bearing mount holes and drive two 3/8" lag screws to hold each bearing in place. I then install two barrel bolts on each side of the flip top. I fish the power cord through the axle and into the junction box, and then install a bushing in the axle hole to protect the power wire. I install the power outlets, run the cords through the frame dados, secure the wires with screw and staples, connect the wires up with wire nuts, and tighten the box connectors. I next move the strain relief into the axle. I apply silicone seal instead of glue so it will be possible to remove it later if the need ever arises. I close the second flip top cover and drive screws into the frame and axle supports. This is the only side that can be opened if any maintenance is ever required, which I indicated with a printed label on the other face. I test that the power outlets are wired correctly and then install the axle cover plate. I use the router with a jig to cut hinge mortises in a series of passes. Turning the jig around allows me to make each mortise extend fully across the edge. I complete the mortise and square up round marks left by the router with some chisel work. I then use the self-centering punch to mark the hinge positions and drill the holes. I attach the cabinet door pulls and then glue the rare earth magnets into the doors and door stops. I duct tape a spacer block to the bottom of the door as a temporary support and then drive screws into the hinges. I attach cleats to both flip-top faces for holding the power wires. I then bolt each saw to the flip-top cart, wrap the power wires around the cleats, and plug them into the outlets. I cut the infeed and outfeed tables out of plywood and attach them to the support brackets with number 12 sheet metal screws. I'm pretty happy with how the infeed and outfeed tables came out. They're easy to operate, and they should work well for woodworking, carpentry, and working with up to moderately heavy pieces of metal. I don't think they're strong enough for working with bigger timbers or heavier pieces of metal. If you apply pressure right at the end here, the table will deflect downward somewhat. So to adjust that, I've got these legs. They hinge down and have a telescoping feature. Now I could install these permanently in all four places, but that would mean every time I operate the infeed outfeed table I have to hinge it down, operate the telescoping feature. It adds extra weight and also makes the cabinet stick out a little bit further. And this is all for the relatively uncommon case of needing to work with heavier pieces of wood or metal. So instead, what I came up with is I installed 4 steel pins in each of the 4 corners of these tables that match the layout of the bracket. That way, most of the time I'll just use it in the simple configuration, but if I ever need extra support, I can put these legs in place. Lower the leg, it's locked in place for moving sideways and adds a lot more strength. So I think that setup should work well. And if I find down the road that I'm using the legs often, I can always change the build and just install these legs permanently.